Welcome back, everyone. We're diving deep today into, well, the really deep past, like way back to the beginning of the universe and the first planets.
Ambitious, yeah.
And get this, our guide is a YouTube video from History of the Universe. It's called, Did the First Planets Come Before the First Galaxies?
A fascinating question.
Definitely. And they cover some seriously mind-blowing stuff, like, planets with glass rain, and then there's like super Saturns with rings so big they'd make ours look tiny, and even the idea that maybe, just maybe, there are ancient civilizations out there watching us right now.
The vastness of the universe never fails to amaze, does it?
It really doesn't. But before we get ahead of ourselves, I think we need to talk about how we even find planets in the first place, because they're so tiny compared to stars right now.
Yeah. I mean, detecting a planet next to a star is often compared to, like, trying to spot a firefly next to a giant spotlight, and that spotlight is incredibly far away.
That sounds pretty challenging.
It is. In fact, early astronomers searching for exoplanets, planets outside our solar system, face a lot of skepticism.
I can imagine. I mean, how do you even begin to look for something so small and faint so far away?
It took some real ingenuity. Astronomers had to develop some clever methods to indirectly detect these planets, relying on subtle clues that betray their presence.
Okay, now I'm intrigued. What kind of clues are we talking about?
Well, one technique uses the Doppler. You know how the sound of a siren changes as it approaches and then moves away from you?
Yeah. It gets higher pitched as it comes closer and then lower as it goes away.
Exactly. Well, light waves do something similar. So as a star wobbles slightly due to the gravitational pull of an orbiting planet, its light spectrum shifts ever so slightly.
Ah, I see. So by analyzing the light from a star, astronomers can detect this tiny wobble and infer the presence of a planet.
Precisely. It's called the radial velocity method, and it was one of the first successful techniques for finding exoplanets.
Wow, that's amazing. But it sounds like a really subtle effect to detect. Are there limitations to this method?
There are. It's most effective at finding large planets that are close to their stars, the kind that cause the most pronounced wobble.
So the Jupiter-sized planets that are practically hugging their stars?
Exactly. Smaller planets, further out, especially those with long orbital periods, are much harder to find this way. But thankfully, astronomers have another trick up their sleeve.
Right, I've heard of that one. This is where you look for a star's light to dim slightly as a planet passes in front of it, right?
You got it. Like a tiny eclipse. Almost imperceptible. But sensitive telescopes like Kepler and TESS, they've revolutionized our understanding of planets using this technique.
It seems like a simple concept, but I bet it takes some serious technology to detect such minute changes in brightness from light.
It does, but the results have been mind-blowing. Thousands of exoplanets discovered, and many of them are unlike anything we ever imagined.
Speaking of mind-blowing, the video we're looking at today showcases some truly bizarre planets. Like there's this one called HD 189733D, and it's blue, but get this, it rains glass there. Sideways.
Yeah, talk about a hostile environment.
Can you imagine trying to open an umbrella there? It'd be shredded in seconds.
More like melted. That rain is actually molten glass particles whipped around by supersonic wind. It just shows the crazy diversity of planetary conditions out there.
It really does. And then there's TRES-2b. This planet's so dark it absorbs almost all light. They call it a black hole planet, but that can't be right, can it?
Not a real black hole, no. It's larger than Jupiter, but it reflects less than 1% of the light that hits it. Imagine something darker than coal.
Wow, so it's like a super stealth planet hiding in plain sight. What makes it so dark?
We're not entirely sure, but it probably has something to do with its atmosphere. Maybe containing some kind of light-absorbing chemicals we haven't encountered before.
Like a cosmic stealth coating? I love it. Okay, but my favorite has got to be J1407b, the Super Saturn. Its ring system is 600 times larger than Saturn. How big is that, really? Could we even see it from Earth?
Oh, definitely. If J1407b replaced Saturn in our solar system, its rings would appear wider than the full moon in the night sky. Absolutely breathtaking.
That's just mind-blowing. It makes Saturn's rings, which we always thought were so grand, look puny in comparison.
Right. It really challenged our understanding of how planetary rings can form and evolve. Clearly, there's still a lot to learn.
Every new exoplanet we find seems to break the mold. It makes you wonder if our own solar system is actually kind of unusual.
That's a question a lot of scientists are wrestling with. The sheer variety of exoplanets suggests that maybe our solar system isn't as typical as we once thought.
Which begs the question, how did all these different types of planets come to be? I know it starts with a protoplanetary disk, but what does that even mean?
Picture this, a huge cloud of gas and dust, mostly hydrogen and helium, left over from a star's birth. This cloud flattens out into a swirling disk, and inside this disk, tiny dust grains start bumping into each other and sticking together.
So like a cosmic game of bumper cars, but with dust?
Sort of. Over millions of years, these dust grains grow into larger and larger clumps.
And those clumps eventually become planets, right?
Exactly. As they grow, their gravity gets stronger, pulling in more material from the disk. Now, close to the star, where it's hot, only heavy elements like iron and silicon can condense. That's where rocky planets form.
So that's how Earth and Mars formed.
You got it. But further out, where it's colder, lighter elements like hydrogen and helium can also stick around. That's where you get the gas giants like Jupiter and Saturn.
It's amazing how this chaotic swirling disk can eventually lead to the beautifully organized structures of planets and solar systems.
Right. It's a testament to the elegant laws of physics.
But here's something that really intrigued me in the video. They talk about this star called TOI 561, which is twice as old as our sun, but it still has planets.
It's a bit of a head scratcher, isn't it?
Yeah. I thought older stars were less likely to have planets.
That's what we used to think. You see, TOI 561 is what we call metal poor. It has very few heavy elements, the stuff planets are made of.
So how did it manage to form planets if it didn't have the building blocks?
That's the mystery. It suggests that maybe planet formation can happen even when there aren't many heavy elements around. Or perhaps there are other ways to form planets that we haven't figured out yet.
And get this, TOI 561 has a super Earth with a 10-hour year. That's crazy.
It is. Imagine having a birthday every 10 hours. Talk about getting older fast.
But seriously, what does finding a planet like that tell us?
Well, for one thing, it shows us that super-Earths, which are bigger than Earth but smaller than Neptune, might be really common even around these ancient metal-poor stars.
So our concept of a normal planet might need some adjusting.
Definitely. And the fact that this planet zips around its star so quickly, it makes us rethink our whole concept of time and planetary orbits.
This is blowing my mind already, and we're just getting started. Now, the video also paints a pretty wild picture of the early universe. It sounds like it was a pretty intense place.
It was. Smaller, denser, more chaotic than it is now. Lots of supernova explosions and intense radiation. Not exactly a welcoming environment.
Yeah, I was going to say, it doesn't sound very hospitable. Hard to imagine anything, let alone planets, surviving in that kind of chaos.
It was a rough time to be around, that's for sure. But that's not the whole story. The video actually suggests that planets might have formed very early on, maybe even within the first billion years after the Big Bang.
Hold on, how is that possible? I thought it took a while for the universe to cool down and for things to settle down enough for planets to form.
Well, the thinking is that as soon as enough heavy elements were created from those first stars and their supernova explosions, the ingredients for planets were there.
So basically, as soon as the universe had the building blocks, it started making planets.
That's the idea. It means there could have been whole generations of planets that existed long before our sun even ignited.
That's a pretty wild thought. But what about those early planets? Could they have actually survived the Wild West of the early universe?
That's a great question. Some were probably destroyed in all the chaos, while others might have been flung out of their systems or even captured by other stars. But the sheer number of planets we see today suggests that at least some of them made it through.
Talk about resilience. Okay, but here's something I found really intriguing. Pulsar planets. How on Earth could planets possibly form or survive around pulsars, which are the remnants of supernovae?
It seems counterintuitive, right? Pulsars are incredibly dense, rapidly spinning neutron stars, blasting out intense beams of radiation. Not exactly a friendly neighborhood.
Yeah, it sounds like the last place you'd expect to find planets.
Right, but we've found them. And it challenges our understanding of planet formation and the extreme conditions they can endure.
So how do scientists explain these pulsar planets? Where did they come from?
There are a couple of main theories. One is that they actually formed from the debris of the supernova explosion itself. Imagine that. All that leftover material, rich in heavy elements, could have clumped together and formed planets over time.
So like phoenixes rising from the ashes of a dead star. That's incredible.
It is. The other theory is that these planets were originally orbiting a companion star to the one that went supernova. Then, after the explosion, the pulsar's powerful gravity might have captured these pre-existing planets.
So like cosmic adoption. Wow.
Yeah, both theories are pretty mind-blowing. It just goes to show that planet formation can occur in the most unexpected places.
And that planets can be surprisingly tough, but could a planet orbiting a pulsar actually be habitable?
That's a tough one. The radiation from the pulsar would make life on the surface pretty much impossible. However, some scientists think that large moons orbiting those planets might offer more shielded environments.
So like underground bunkers on a moon, protected from the deadly radiation.
Exactly. And if tidal forces from the planet generate heat within the moon, well, who knows what might be possible.
This is all so fascinating. It seems like everywhere we look in the universe, we're finding planets that challenge our assumptions about where planets can form and what conditions might be suitable for life.
It's a constant reminder that we still have so much to learn about the universe and the incredible diversity of worlds it contains. And speaking of challenging assumptions, we haven't even touched on Haen worlds yet.
Haen worlds! Those are new to me. What are they like?
Think bigger than Earth, shrouded in a thick hydrogen atmosphere, and with a global ocean underneath.
Wow, a planet-wide ocean. Sounds amazing, but wouldn't the pressure at those depths be crushing? Could anything actually survive down there?
The surface conditions might be rough, but the deep oceans, protected by that thick atmosphere, could be more stable. And remember, life finds a way, even in places we might consider extreme.
You're talking about extremophiles again. Those organisms that thrive in conditions that would kill most other life form. Are you suggesting that these Haen worlds could be teeming with these unique creatures?
It's definitely a possibility. Haen worlds really expand our understanding of what habitable might mean.
And if these Haen worlds exist now, is it possible that they formed in the early universe too?
That's what researchers are trying to figure out. If a rocky core could form early on and quickly grab a big hydrogen atmosphere, then a global ocean might not be far behind. It would mean that even though the early universe was chaotic, it could also have been surprisingly good at making these potentially habitable worlds.
So while we've been focusing on finding rocky planets like Earth, maybe these Haen worlds are the real hidden gems, potentially hosting some of the oldest life in the universe.
It's an exciting prospect, isn't it? They highlight just how important it is to keep an open mind when searching for life beyond Earth.
Well, my mind is definitely wide open after all this. We've gone from barely knowing any exoplanets to realizing how plentiful and diverse they might be. And some of them might even have life, very different from our own. Okay, but let's get back to Methuselah first. This ancient planet, almost as old as the universe itself, how can they even be possible?
Methuselah is a gas giant, over twice the mass of Jupiter, orbiting a pulsar in a globular cluster. And you're right, its age is mind-boggling, 12.7 billion years old.
It's almost like it's been around since the beginning of time. It must have seen some incredible things. But how could it survive for so long, especially around a pulsar? They're the remnants of supernovae, some of the most powerful explosions in the universe.
It's a question that's baffled scientists for years. The intense radiation and gravity from pulsars make them seem like the least likely places to find planets, let alone ones that can last for billions of years.
It sounds like a death sentence for any planet that gets too close. So how did Methuselah manage to survive?
Well, one theory is that it formed around a regular, sun-like star that later evolved into a pulsar. Another possibility is that it was kicked out of its original system and then captured by the pulsar's gravity.
So either a slow dance of death or a cosmic game of capture the flag. Either way, it's a pretty epic tale of survival.
Agreed. To witness the death of its original star and the birth of the pulsar it now orbits, that's quite a journey.
But wouldn't a gas giant like Methuselah be inherently hostile to life?
Methuselah itself, yeah, probably not the best place for life as we know it. But remember, gas giants often have moons, and those moons can be incredibly diverse.
So you're saying there could be a moon orbiting Methuselah, shielded from the pulsar's radiation, where life could exist. And given the age of the system, that life could be billions of years old.
It's a possibility that's truly mind-blowing. A moon orbiting Methuselah could be a world of its own, maybe with oceans and atmosphere and who knows what else. And if life arose there billions of years ago, imagine how advanced it might be now.
It really puts things into perspective, doesn't it? Our civilization, a mere blip in cosmic time compared to potentially ancient life out there.
It certainly makes you wonder what else might be out there. This deep dive has really shifted my perspective on the scale of the universe and the vast possibilities that exist.
Me too. Okay, after all this talk about ancient planets, Haen worlds, and moons orbiting pulsars, I think I need a moment to collect my thoughts. This has been a lot to process.
Take your time. It's a lot to absorb, but we're not done yet. There's one final twist to this deep dive that's sure to leave you pondering the true scale of the universe and our place within.
Wow, I am still trying to wrap my head around all of that, from glass rain to super Saturns to planets around pulsars. Where do we go from here?
Well, after exploring those distant and sometimes extreme systems, the video takes us a little closer to home, to our own solar system, specifically the Kuiper Belt.
Oh, right, the Kuiper Belt, way out beyond Neptune. Isn't that where Pluto hangs out?
Exactly. It's like a cosmic deep freeze full of icy leftovers from the early days of our solar system. And among those leftovers, there's this really interesting object called Arrokoth. It's not a planet, but it's fascinating in its own right.
Okay, so we're going from these huge, mind-boggling planets to a little icy object. How does that help us understand the first planet Earth?
Well, think of it this way. The universe tends to build things in stages, starting with simple structures before moving on to more complex. So stars form before planets, and smaller, simpler objects probably came before the bigger, more elaborate planets we see today.
Ah, I see. So Arrokoth, this little clump of ice and dust, it's like a snapshot of the very first solid objects that formed in the universe, way back when.
Exactly. It's like a time capsule, preserved in the deep freeze of the Kuiper Belt for billions of years. By studying Arrokoth, we're essentially looking back in time, getting a glimpse of the processes that led to the formation of the first planets everywhere.
It's amazing that something so small and seemingly insignificant could hold such important clues about the early universe. So even though it's not a planet, Arrokoth is still a crucial piece of the puzzle when it comes to understanding how the building blocks of planets first came together.
Right, and here's another key point. Objects like Arrokoth are incredibly tough. They've survived all sorts of cosmic events, supernovae, gravitational disruptions, things that might have wiped out entire planetary systems.
So while those early planets we talked about might have faced a rough time in the chaotic early universe, these simpler objects could have weathered the storm and survived.
That's the thinking. They're like cosmic survivors, holding on to secrets from the very beginning. Now, Arrokoth itself is pretty unlikely to have life, being so far from the sun and incredibly cold, but its very existence hints at something profound. Even in the very early universe, solid objects were forming, setting the stage for planets and maybe eventually life.
Okay, I am starting to grasp the sheer scale of this. We're talking about processes that played out billions of years ago, across the vastness of space. It makes you realize how much we still don't know about the universe's early history.
And with every discovery, it seems like more questions pop up than answers.
Well, that just makes it more exciting. Okay, but can we circle back to those Haitian worlds for a minute? You said they challenge our ideas of what conditions are needed for life?
Yeah, they're pretty wild. Imagine a planet much larger than Earth with a thick hydrogen atmosphere, and then underneath that, a global ocean.
Planet-wide ocean. That's incredible. But wouldn't the pressure down there be crushing?
The surface, yeah, probably not very welcoming, but the deep oceans, protected by that thick atmosphere, might be much more stable. And we've learned that life is surprisingly adaptable.
You keep mentioning these extremophiles. Are you suggesting that these Haitian worlds could be teeming with life, just not life as we know it?
It's a fascinating possibility, right? They push us to expand our definition of what habitable could mean.
So if Haitian worlds are possible now, could they have formed way back in the early universe too?
That's a hot topic in astrophysics right now. The thinking is, if a rocky core formed early on and quickly grabbed a bunch of hydrogen, well, a global ocean might not be too far-fetched.
So while we're looking for Earth-like planets, these Haitian worlds could be hiding in plain sight, maybe even holding some of the oldest life in the universe.
Exactly. It's a good reminder to stay open to the unexpected.
My mind is officially blown wide open. This deep dive is making me rethink everything I thought I knew about planets and the potential for life out there. But let's bring it back to Methuselah for a moment. This ancient gas giant orbiting a pulsar, how on earth did it manage to survive for 12.7 billion years?
It's an incredible feat of survival, isn't it? Especially considering the environment. Pulsars are remnants of supernovae, incredibly dense, rapidly spinning neutron stars, and they emit these powerful beams of radiation.
Not exactly the most welcoming neighborhood for a planet. So how did Methuselah manage to escape destruction?
Well, there are a couple of leading theories. One is that it originally orbited a star that later became a pulsar. As the star died and went supernova, somehow Methuselah survived.
Talk about being in the wrong place at the right time. Or maybe the right place at the wrong time, I'm not sure.
Right. The other idea is that it was originally part of a different star system altogether, and they got kicked out, went rogue, and then, by chance, got captured by the pulsar's gravity.
So like a cosmic game of pinball.
Pretty much. Either way, it's an amazing story of survival against all odds. To have witnessed the death of its original star and the birth of the pulsar it now orbits, that's something else.
It's hard to even imagine what that would be like. But isn't it unlikely that a gas giant like Methuselah could have life?
On the planet itself, yeah, probably not. But we have to remember that gas giants can have moons, and those moons can be incredibly diverse.
So, are you suggesting that there could be a moon orbiting Methuselah, shielded from the pulsar's radiation where life could exist? And because the system is so old that life could be billions of years old?
It's a possibility that really sparks the imagination, doesn't it? A moon orbiting Methuselah, maybe with oceans and an atmosphere, a world of its own. And if life did arise there billions of years ago, think of how it might have evolved.
It's mind-blowing to think that our civilization, just a few thousand years old, might be a newcomer compared to potentially ancient life out there. This whole deep dive is really making me question our place in the grand scheme of things.
That's the power of exploring these cosmic concepts. It pushes us to expand our understanding of the universe and the incredible diversity of worlds it might hold.
I'm definitely feeling a sense of awe and wonder right now. Okay, after all this talk about ancient planets, Haitian worlds, and moons orbiting pulsars, I think I need a moment to let it all sink in.
Take your time. These concepts can be a lot to process, but we're not done yet. There's one final twist to this deep dive that's sure to leave you pondering the true scale of the universe and our place within it.
All right, I'm ready for that final twist. You said it might make us rethink our place in the universe. Lay it on me.
Well, remember all that talk about ancient civilizations observing us from afar? What if I told you there might be evidence for that right here in our solar system?
Wait, hold on. You're saying there might be something in our cosmic neighborhood that suggests we're being watched. Okay, now I'm really curious. Tell me everything.
Have you heard of KIC 8462852? It's a star that astronomers have nicknamed Tabby's Star.
Tabby's Star. Yeah, it rings a bell. Didn't it have some weird light patterns or something?
You've got a good memory. Back in 2015, astronomers were looking at data from the Kepler Space Telescope, and they noticed something really strange about Tabby's Star. It was dimming in ways that we just couldn't explain with any natural phenomenon.
So not like the usual dimming we see when a planet passes in front of a star.
Nope, this was different. It was irregular, unpredictable, and way more dramatic than anything a planet could cause. Some of those dips in brightness were like 22%.
22%, that's a huge drop. What could possibly cause a star to dim that much?
That's the big question. And it's led to a lot of speculation. Some people think it could be swarms of comets or maybe giant dust clouds. But there's another, more out there idea: alien megastructures.
Alien megastructures. Okay, now you're talking my language. What kind of megastructures?
Imagine a civilization so advanced that they can build these huge structures in space, maybe to collect energy from their star. As those structures move around, they would block some of the starlight, causing the dimming we see from Earth.
So like a giant construction project in space, aliens building something massive around their star.
It sounds like science fiction, I know. But the alien megastructure hypothesis, however unlikely, shows how important it is to consider all the possibilities, even the crazy ones.
This whole deep dive has been full of surprises. From glass rain to pulsar planets to those Haen worlds, we've seen how much we still don't know about the universe. So yeah, maybe alien megastructures aren't so far-fetched after all.
It's all about keeping an open mind, right? The universe is full of wonders, and we've barely scratched the surface.
This whole journey has been incredible. We started by asking when the first planets formed and ended up contemplating alien megastructure. Who knew?
It's a great reminder that our planet, our solar system, even our galaxy are just tiny parts of this vast universe.
And yet, even in those tiny parts, there's so much complexity, so much diversity, and so much left to discover. What an amazing thought.
It really is. And the search for the first planets isn't just about the distant past. It's about understanding our place in the universe, how we got here, and whether we're alone.
I've got to say, this deep dive has left me feeling both humbled and excited. Humbled by how much we still don't know, but excited by all the possibilities out there.
That's the beauty of it all, isn't it? The universe is full of mysteries, and we're just starting to unravel them.
Well, thanks for taking us on this incredible journey through time and space. I feel like I've learned so much, and I can't wait to see what other wonders we uncover in the future.
The exploration never ends. Until next time, keep looking up and keep wondering.